Yeah, so hello everyone. As it is mentioned here that we are going to start the topic of binary search. So first of all, let me tell you that what is binary search actually. Okay, mm, let me change my mouse so that it can be pencil. Yeah, so let's know about the binary search, like what is the binary search and all. Right. So the binary search is something is the searching algorithm, I can say. It is a searching algorithm. Okay, and like we have the linear search also. Linear search. In linear search, what we will do, like we have an array 2, 3, 4, 5, 6, 7, 8, and we need to find the 8, like on which index it is present 8. So what we do, what we run a loop like a for loop or any while loop, okay, something like this, and then we run a loop accordingly and it will go linearly and check like where it is present. So that's how linear search work. But what is binary search? Binary search is a optimized version of searching. Like the linear search, it take the order of n time complexity. But the linear search is something which take very less time. It take log n, log n time. Okay, login time, and which is very less time as compared to this. Okay, so that's how the things work and in the time complexity. But let me tell you that how we can go with this approach and how this approach can be work. So let me show you that also. Suppose we have an array 1, 2, 3, 4, 5, wait, 5, 6, and 7. This is the very mandatory thing in binary search, that it should be the array should be sorted. Okay, this is very important thing, that array should be sorted. Binary search can only work with the sorted array. Now the second thing, what we do, we take a mid value. We find a mid, and then accordingly, suppose in this array, this is the mid. Now, on the second iteration, it will go to, suppose my k value, like the value which I need to find is 3. Okay, I need to go till 3. So that time, what will happen? This is the mid. So it will do something like this, that it next time it will go only this much. Then it will see that my k is lying somewhere this much. So on second iteration, like when it find that what is mid between those, we can consider the 3 as mid. So now next time 3 will move and it will check in these both. So that's how, see, just in 2 iteration everything completed. Otherwise we have to do something like this. Yeah, linear searching. But right now, just we will move our pointer in such a way that in 2 iteration we found our 3. Now, why, how we will do it? First of all, we will find the met. How we can find the met? This is the I. Let's take the initial point as I and take last pointer also. We are keeping it as J, which is n minus 1. N minus 1 means its index. And we will find our mid by I plus J divided by 2. So when we divide it like this, or like by plussing in both of them and then finding the mid, so we can find the mid as, can be this one. Yeah. So 4 will be mid. This mid will contain the index of that 4, which is 3. Right? Now on second time, what we will do? We found the mid. We found a mid. Now we will use 3 condition here. 3 conditions to finding our main element. Either our condition can be mid can be greater than k, or mid can be smaller than k, or mid can be equal. equal to b, right? These three cases can be there. Like mid is the index, so we can say that index of element of that mid. So that's all. Like element, we need to compare the element. Array of mid should be either greater than of k, should be lesser than, or can be equal, right? So that's all. Yeah. So let's move to the code part. We are going to do a code to find the mid value by its means by the binary search. Let's take one array as 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, comma 9, comma 8. But keep in mind always that it should be shorted, nothing else. If array is not shorted, first short it, then start for binary search. Now we are taking our initial point and the last point as length of array -1. So that's how we can access the last index. So in J, we are putting our last index. Now we will run a while loop here. But this while loop will not run linearly, right? Now means how we can do this, that it will not move linearly just by those three conditions that we mentioned in the X carry row. Yeah. So first of all, we need to find our mid. We will find our mid by I plus j divided by 2. Divide by 2. Now we will use our three condition. If array of mid is equals to k. Now what is the k? Let's assume a k as 3. Okay. But it is great equals to k. So what we can do here, um, we can print we can print our mid, and then we can break the loop because we found the element. That's why we can break it out. Now there can be another case when mid is greater than k. Now this time what we can do it like we can move our I pointer. Suppose I pointer is here and mid is here, and our array of mid is greater. Like whatever we found in is here is greater than the k value. K value is 3 and it is greater. So that time we should not move our I. We can move our j if this condition is happening. So we can move our j as mid -1, and there can be the last condition, else condition. In else, we can say that mid should be +1. So I will show you the dry run also. Just wait. Else we can say print not found, right? If element is not found, so we can say that not found. Let's run it out. Like 2 is coming. Like 3 is present at 2 index now. So that's why it is saying something like this. Let's go with the 9 and let's check is it giving the index or not. Yeah, so it is giving the index for 9 also. Let's go with the 12, which is not present in this array. So now this time it will go to the else part, not found. Now let me show you its dry run, that how the things is working. So we have this, yeah, we have this. Let's change our point color and change the this also. Now see, this is our array 1, 2, 3, 4, 5, right? Yeah. So we have this array and we have k as suppose 3. We are just going to dry run with the 3. So we will found the 2 index. Like this is the 0, 1, 2, 3, 4, 5, 6, 7, or 8. Right? These are the index of this array. Now we have the I as startingly 0 and j as 8. Right? And suppose when I is less than or equals to j, so we are going to find the mid. Mid, what will be the mid? 0 plus 8 divided by 2, which will be the 4. And on 4, what is present? It is 5, right? So in the next condition, area of mid. Area of mid means 5. Is 5 is equals to k? No. So it will not go in this condition, like it right here, like on first iteration, it will not go in this. It will go in this one because area of mid, which is 5, 5 is greater than 3, right? So that's why it will go here and it will move the j pointer. So this time j will be become mid minus 1. Mid minus 1 means it will come on 3. So j will become 3 this time. Now, in short, we can say we are just ignoring these all elements now. We will not come back on this element again in future or next iteration. Okay. So right now our I become 0 and j become k. And again, while condition will go, it will say that I is greater than or equals to j. So yeah, I is greater means I is smaller or equals to the j. We will find the mid again. We are going to find the mid again. 0 plus 3 divided by 2, which is nothing but the 2. Because it will like when we divide it, it will become 1.2, 1.5. But we are doing double this. So it will go on the floor value. Floor value is nothing but the true 2. So that's how we got that floor value. And we found our mid as this one. Let me do it something like this more so that I can show you here. Right? So it becomes this. Okay, maybe it is not properly clear right now. So let's move here and let's do here. Now, our mid become 2. So see, array of mid. Array of 2 is equals to k or not? Array of 2 is 3, which is equals to k. So it will return the k. Just in 2 loop, it worked. And same on, you can dry run within 9 also. When we do it with 9, it will first go here. And in this, it will find the mid. And then it will go on this next, suppose. Let's me do it with the k. But I'm not going to write and doing the proper code and all. I hope you understand it that I'm not going to dry run fully, but I'm just going to show you little bit. Now, see, suppose this k value is 9. So what will happen? This is 1, 2, 3, 4, 5, 6, 7, 9 or 10. So first of all, we found our mid as 5. So now in next time it will go on 5, 6, 7, 9 or 10. This will become the I. I will become this one. Okay, I will become this one because mid is on this. So next time we will go on these 4 element and J is this. Again it will find the mid. What can be the mid? This can be the mid. So on next time it will check on this much part. Can be the possible or can be found on this much the part. So on just on 2 loop, it will complete. Suppose we have very big array. We have array with this much and lots of things are going on. That time that middle, first of all, it will go on the half part. Then for that, I'm just so sorry about it that I'm making very bad drawing. Suppose this is our array. Lots of element is present inside it. First of all, it will go half of it. On the next iteration, either it will move here or move here. Then again it will find the mid. Suppose this is the mid or this is the mid. On next iteration, either it will go here or will go here. Again it will find the mid. Either it will go in this much part or this much part. This much part or this much part. Right? So suppose this on here it came. Now it will find the here. So that's how it is dividing the array On at each iteration, it is dividing the array in half. And just because of this optimization, its time complexity is nothing but the log n. But when we need to short it also, so we can say that n log n, right? N log n. So I hope you understand about the binary search more properly, whatever I shared you, like dry run also, and the proper explanation that how binary search work and especially its time complexity.